Welcome to Litmus Chemistry classes. So, in the first part of this chapter, we have learnt what the valence bond theory along its postulate. So, in the second part, we have discussed what the application of the valence bond theory for a given coordination complex with a coordination number 4 and coordination number 6. So now, even though the valence bond theory was giving us so much of the information about the coordination complex, be it about hybridization or a geometry or a magnetic property or even the high spin or the low spin type of complexes, we can decide with the help of VBT, that is valence bond theory. Astella iddu kuda, even though the VBT was giving so much of information about the coordination complex, it has some of the shortcomings or the limitations. Yes, even the VBT also failed to express some of the concepts for the coordination complexes. So in that the first thing is I want to mention here is, remember one thing, valence bond theory. Remember one thing, valence bond theory was not at all applicable for the ligands. Remember one thing, what type of ligand it is, like whether it is a strong ligand or a weak ligand, all those things were not at all studied with the help of valence bond theory. With respect to ligands, I am discussing here. With respect to ligands, what type of ligand it is, either it is a strong ligand or a weak ligand, was not at all studied with the help of valence bond theory. For that thing, we require spectrochemical series or the crystal field theory, and even the ligand field theory explains the the type of the ligand. VBT never explains the what type of ligand it is, that is whether it is a strong ligand or a weak ligand. So here, making that point into consideration, let us see the limitations of VBT. And the first limitation of the VBT is qualitative in nature. So remember one thing, VBT is it's a qualitative in nature. It is just a pictorial thing to express how the bonding is taking place. Okay, we have seen how to applicable for the VBT, how it applied on the given coordination complex. There also we have seen in a pictorial way how the ligands are pairing up with the orbital, that is metals orbital, that is vacant hybrid orbital nalli ligand ಯಾವ ರೀತಿಯಾಗಿ pair up ಆಗುತ್ತೆ, electron donate ಮಾಡುತ್ತೆ ಅಂತ ಅಷ್ಟೇ ಕಲಿತಿದ್ವಿ. So on that note, it doesn't have a strong fundamental or the theoretical aspects in order to explain the bonding in the coordination complexes. So hagagine VBT is just a qualitative nature. It is having a qualitative nature. Why? Because it doesn't have a strong fundamental theoretical explanation for the bonding which is taking place between the metal orbital and the ligand. It is just a pictorial way to show how the bonding is taking place. That's it. So hagagi, the first postulate is VBT is qualitative in nature. VBT is it's a qualitative in nature. And second very important limitation is VBT didn't explain anything about the color as well as the spectra of the coordination complexes. See, many of the coordination complexes are having some colors. They are having some colors, and even they show some of the bands. So here with respect to VBT, it never discussed about the color of the coordination complex. Color ಬಗ್ಗೆ ಎಲ್ಲೋದು ಹೇಳಲಿಲ್ಲ. So ಹಾಗಾಗಿ the second limitation is VBT doesn't explain about the color and spectra of the complexes. And the third very important limitation is VBT doesn't explain the magnetic moment of the coordination complexes. So here in VBT, ನೀವು ಹೇಳ್ಬೋದು ಸರ್, ಹಾಗಾದರೆ we were discussing about the paramagnetic property and the diamagnetic property ಅಂತ. See here, the magnetic momentum is given with the help of mu. Mu is equal to mu is equal to the magnetic momentum is it is given with the help of the contribution of the electron spin as well as the contribution of the orbital motion. Remember one thing, ಏನು ಒಂದು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೊಮೆಂಟಮ್ ನಾವು ಹೇಳ್ಬೇಕಂತಂದ್ರೆ ಆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೊಮೆಂಟಮ್ ಅಲ್ಲಿ ಇಬ್ಬರು ಕಾಂಟ್ರಿಬ್ಯೂಷನ್ ಬರುತ್ತೆ. ಒಂದು ಇಟ್ ಇಸ್ ಅ ಸ್ಪಿನ್ ಆಫ್ ದಿ ಇಟ್ ಇಸ್ ಅ ಮೋಷನ್ ಆಫ್ ದಿ ಎಲೆಕ್ಟ್ರಾನ್ or spin of the electron, and another one is the it's a motion of the orbital. But here according to VBT mu was only expressed with the help of the spin of the electron. ಅಷ್ಟೇ, only the spin of the electron was considered in VBT, but the orbital motion, the contribution of the orbital motion was not at all taken into consideration with respect to VBT. So hagagine, whenever the complex was examined, ಯಾವಾಗ ನಾವು ಒಂದು ಕೋಆರ್ಡಿನೇಷನ್ ಕಾಂಪ್ಲೆಕ್ಸ್ನ ಸ್ಟಡಿ ಮಾಡ್ತೀವಿ ಅವಾಗ ಏನು ತಿಳಿದು ಬಂತಂತಂದರೆ ವೆರಿ ಸಿಂಪಲ್ ಥಿಂಗ್, ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೂಮೆಂಟಮ್ ವಿಚ್ ವಾಸ್ ಫೌಂಡ್ ಔಟ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟಲಿ ಫೌಂಡ್ ಔಟ್ ಮಾಡಿರೋದನ್ನು ಎಷ್ಟು ಬಂತು, ಹೈ ಬಂತು ವ್ಯಾಲ್ಯೂ. ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೊಮೆಂಟಮ್ ಫಾರ್ ದಿ ವಾಟ್ ಕಾಂಪ್ಲೆಕ್ಸಸ್ ವಿಚ್ ವೇರ್ ಸ್ಟಡಿಡ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟಲಿ ವೇರ್ ಹ್ಯಾವಿಂಗ್ ವಾಟ್ ಹೈಯರ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೊಮೆಂಟಮ್, ವೈಲ್ ದಿ ಥಿಯರಾಟಿಕಲ್ನಲ್ಲಿ ಚೆಕ್ ಮಾಡಿದಾಗ ಏನು ಬಂತು, ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೊಮೆಂಟಮ್ ವಾಸ್ ಲೋ. ವೈ? ಬಿಕಾಸ್ ದ VBT only takes the consideration of what electron spin, but the orbital motion ಬಗ್ಗೆ ಅದು ಎಲ್ಲೂ ಹೇಳಲಿಲ್ಲ. Understood? So in order to find out the what magnetic momentum, you should have two things here. You should consider two things. One is the what magnetic moment because of the what the spin of the electron, and magnetic moment because of the orbital motion. Here just we are seeing what whether there is an unpaired electron is present or the paired electrons are present. If there is unpaired electron, it's a paramagnetic. If it is a paired electron, it is diamagnetic anta helbiಡ್ತೀವಿ. But here the thing is, we never discussed about the orbital motion. So in order to explain the magnetic momentum in detail, it is we need to consider two things. One is spin, another is orbital motion. But according to VBT, it only consider what the spin of the electron, not the what it doesn't explain about the magnetic momentum because of the contribution of orbital motion. ಹಾಗಾಗಿನೇ experimental value high ಬಂತು, theoretical value low ಬಂತು. This was a very important the failure of VBT with respect to magnetic momentum. So the third limitation here is very simple thing. VBT doesn't explain the splitting of d orbitals after the complexation. See here. ಸೊ ಯಾವಾಗ ಬೇರೆ ಬೇರೆ ಥಿಯರೀಸ್ ಎಲ್ಲವೂ ಕೂಡ ಬಂತಲ್ಲ, ಲೈಕ್ CFT, ಕ್ರಿಸ್ಟಲ್ ಫೀಲ್ಡ್ ಥಿಯರಿ, ಲಿಗ್ಯಾಂಡ್ ಫೀಲ್ಡ್ ಥಿಯರಿ, ಇನ್ ಆಲ್ ದೋಸ್ ಥಿಂಗ್ಸ್, ಎಸ್ ದ d orbital was splitting up into what lower energy level and the higher energy level. So according to VBT, we have seen the application of VBT. There the metal d orbitals were not at all split up. So but the actual thing ಏನಾಗುತ್ತೆ, the metal d orbital will split up into two energy levels. One acts as lower energy level and another acts as what the higher energy level. It depends upon the what, again it depends upon the octahedral as well as the tetrahedral complexes. ಅದು ಬೇರೆ ಬೇರೆ ಆಗುತ್ತೆ. Yes, the next part is crystal field theory only. There we will discuss how the d orbitals are splitting up into two energy levels like T2g and EG. All those things we will learn. So before here the thing is what, it never explains about the what the splitting of the d orbital. So complex ಆಗಬೇಕಾದ್ರೆ splitting of the d orbital ಬಗ್ಗೆ ಅದು ಎಲ್ಲೂ ಹೇಳೋದಿಲ್ಲ. So ಹಾಗಾಗಿ VBT doesn't explain about the what the splitting of d orbital. And the very important fifth postulate, see here. ನಾನು ಮೊದಲೇ ಹೇಳಿದ್ದೆ ಏನು, that is VBT VBT never explains about the type of the ligand, whether a strong ligand or a weak ligand. So ಹಾಗಾಗಿನೇ if you see here, VBT doesn't explain why some complexes of metal ion, in a particular oxidation state shows high spin and low spin property. So ಯಾವಾಗ high spin ಯಾವಾಗ low spin, ಹಾಗಾದ್ರೆ we know that when there is a strong ligand is there, the electron will be paired up. The electron pair up ಆದರೆ d orbital ನಲ್ಲಿ, that we call it as what inner orbital complex, and inner orbital complex are what low spin complex ಅಂತ ಹೇಳಿದ್ವಿ. ಅದೇ ರೀತಿಯಲ್ಲಿ for about the what high spin complex ಅಂದ್ರೇನು, outer orbital complex, that means weak ligand ಇರಬೇಕಂತ ಹೇಳಿದ್ವಿ, ಹೌದಾ? But here the thing is, VBT ligands ಬಗ್ಗೆ ಎಲ್ಲೂ ಹೇಳೋದಿಲ್ಲ. VBT never explains about the what type of ligand it is. So ಹಾಗಾಗಿನೇ see the example here, in both CONH taken 6 times plus 3 and COF6 taken COF6 3 minus complex ions. In these two ions the cobalt is present in plus 3 state only. ಇಲ್ಲೂ ಕೂಡ plus 3 state, ಇಲ್ಲೂ ಕೂಡ plus 3 state. Okay, but the thing is what, the first one acts as the low spin complex, second one acts as the what high spin complex. Low spin complex ಯಾವಾಗ, that is D2sp3, high spin complex ಯಾವಾಗ sp3d2. ಇದು ನಮಗೆ ಗೊತ್ತು ಸರ್, ಹೌದಾ? D2sp3 ಆದರೆ ಲೋ ಸ್ಪಿನ್, sp3d2 ಆದರೆ ಹೈ ಸ್ಪಿನ್. n-1d ಆರ್ಬಿಟಲ್ ಇನ್ವಾಲ್ವ್ ಆದರೆ ಲೋ ಸ್ಪಿನ್, nth ಆರ್ಬಿಟಲ್ ಇನ್ವಾಲ್ವ್ ಆದರೆ ಹೈಬ್ರಿಡೈಸೇಷನ್ ಅಲ್ಲಿ ದಟ್ ಈಸ್ ಹೈ ಸ್ಪಿನ್, ಹೌದಾ? So these things were there. Even though VBT didn't explain anything about the type of the ligand, it was confusing that whether the metal ion in a particular oxidation state shows high spin or low spin. ನಮಗೆ ಆಮೇಲೆ ಗೊತ್ತಾಯಿತು ligand ಬಗ್ಗೆ. Later we got to know about that. Yes, these ligands come under strong field ligand and these ligands comes under the what weak field ligand ಅಂತ. So ಅದಕ್ಕಿಂತ ಮುಂಚೆ there was a huge confusion. Why? Because now we know that what type of ligands we are seeing in the what coordination complex, but without any idea about the ligands, you can't explain the what, whether the given thing is a low spin complex or the high spin complex. Even though the metal is having what, the +3 state in both the complexes, cobalt +3 ಇದೆ ಇಲ್ಲೂ ಮತ್ತು ಇಲ್ಲೂ ಕೂಡ, but the thing is what, it fails to distinguish between whether the CO+3 shows high spin or whether the CO+3 shows what, low spin. ಯಾದಕ್ಕೆ? ಬಿಕಾಸ್ ಆಫ್ ದಿ ಲಿಗ್ಯಾಂಡ್. ದೇರ್ ವಾಸ್ ನಾಟ್ ಅ VBT ನೆವರ್ ಡಿಸ್ಕ್ಲೋಸಸ್ ಆರ್ ನೆವರ್ ಸ್ಟಡೀಸ್ ಅಬೌಟ್ ದಿ ವಾಟ್, ಲಿಗ್ಯಾಂಡ್ಸ್. ಸೊ ಹಾಗಾಗಿ ತಲೆಯಲ್ಲಿ ಇದನ್ನು ಇಟ್ಕೋಬೇಕು. ಓಕೆ, VBT ನೆವರ್ ಎಕ್ಸ್ಪ್ಲೇನ್ಸ್ ಎನಿಥಿಂಗ್ ಅಬೌಟ್ ದಿ ವಾಟ್, ದ ಸ್ಟ್ರಾಂಗ್ ಫೀಲ್ಡ್ ಆರ್ ದಿ ಟೈಪ್ ಆಫ್ ದಿ ಲಿಗ್ಯಾಂಡ್. ಓಕೆ, ಎಸ್. And the sixth point here, VBT doesn't explain, this is a very important thing here, didn't explain why CuNS is taken 4 times +2 and similar complexes show square planar geometry and not tetrahedral geometry. So this was what very very important limitation of the VBT. Yake? Again the same thing, confusion here. For example, okay, nickel Cl4 2- is there. In the same way, NiCN4 2- is there. See here, both these two complexes are having what, coordination number 4 now. Coordination number 4. If you find out the oxidation state of nickel, it will end up with what, Ni+2 only. ಎರಡರಲ್ಲೂ ಕೂಡ Ni+2 state ನಲ್ಲೇ ಇದೆ. So even though Ni is showing in both the complexes, even though Ni is having what, +2 state only, one is showing what, square planar, another one is showing what, another one is showing the tetrahedral geometry. ಹೌದಾ? So ಹಾಗಾಗಿನೇ see here, NiCl4 acts as what? It is a what? It's a tetrahedral one. It's a tetrahedral sp3 or hybridization. NiCN4 source dsp2 hybridization. See here. ಹೌದಾ? ಎದಕ್ಕೆ dsp2 hybridization? Because of the strong ligand, because of the weak ligand ಅಂತ ಹೇಳ್ತೀವಿ. But the thing is what? VBT never explains about the type of the ligand here. Again the confusion starts. So whenever the coordination number 4 is there, that means what? Either the coordination complex is having what? Tetrahedral or square planar. Confusion. Yake? Because before, see, now we are knowing about the type of the ligand. So before I am explaining, before the things were known about the ligands, our confusion ittu, because Ni+2 ಎರಡರಲ್ಲೂ Ni+2 ಇದೆ, ಒಂದು ಸ್ಕ್ವೇರ್ ಪ್ಲಾನರ್ ಮತ್ತೊಂದು ಟೆಟ್ರಾಹೆಡ್ರಲ್ ಅಂದ್ರೆ, yes, there was some confusion to what, to in order to study the geometry ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಬೇಕಾದ್ರೆ ತುಂಬ ಕಷ್ಟ ಆಗ್ತಾ ಇತ್ತು. ಸೊ ಲೇಟರ್ ವಿ ಗಾಟ್ ಟು ನೋ ಅಬೌಟ್ ದಿ ವಾಟ್, ದ ಟೈಪ್ ಆಫ್ ದಿ ಲಿಗ್ಯಾಂಡ್ಸ್. ಆಮೇಲೆ ನಮಗೆ ಟೈಪ್ ಆಫ್ ಲಿಗ್ಯಾಂಡ್ಸ್ ಗೊತ್ತಾಯಿತು. ಓಕೆ, ದಿಸ್ ಇಸ್ ಸ್ಟ್ರಾಂಗ್ ಲಿಗ್ಯಾಂಡ್, ದಿಸ್ ಇಸ್ ವೀಕ್ ಲಿಗ್ಯಾಂಡ್ ಎಲ್ಲ ಗೊತ್ತಾಯಿತು. ಸೊ ಇನ್ ದ ಸೇಮ್ ವೇ ದ ಎಕ್ಸಾಂಪಲ್ ದಟ್ ಇಸ್ CuNS3 ನೀವು 4+2 ನೀವೇನಾದರೂ ನೋಡಿದರೆ ಇಟ್ ಶೋಸ್ ವಾಟ್, ಇಟ್ ಶೋಸ್ ದಿ ಸ್ಕ್ವೇರ್ ಪ್ಲೇನಾರ್ ಜಾಮಿಟ್ರಿ. ರಿಮೆಂಬರ್ ಒನ್ ಥಿಂಗ್, CuNS3 taken 4 times +2 complex ion ಏನಿದೆ, it shows what, a square planar geometry but tetrahedral ಅಲ್ಲ. So why ಅಂತ ನೋಡಿದಾಗ, according to what, electron spin resonance studies, ESR studies ಮಾಡಿದಾಗ ಏನು ಗೊತ್ತಾಯಿತು, the coordination number 4 having is what, it is a square planar ಅಂತ ಗೊತ್ತಾಯಿತು. But now I will give you a task now. ಇವಾಗ ನಾನು ನಿಮ್ಗೊಂದು ಟಾಸ್ಕ್ ಕೊಡ್ತೀನಿ. Apply the VBT for CuNS3 taken 4 times +2 and see what difficulty you will face. Okay, ಒಂದ್ಸಲ ಇದಕ್ಕೆ ಅಪ್ಲೈ ಮಾಡಿ, ಏನನ್ನ, VBT ಅನ್ನ ಅಪ್ಲೈ ಮಾಡಿಬಿಟ್ಟು just try to find out which hybridization it is undergoing, either dsp2 or sp3 hybridization. Why? Because Cu is having what atomic number? Okay, Cu is having the atomic number 29. So that is what, argon 3d10 4s1. ಹೌದಾ? Argon 3d10 4s1. Okay, it shows the anomalous behavior of electronic configuration in order to attain the stability. ಇದೆಲ್ಲ ಕೂಡ ಕಲ್ತಿದ್ರಿ ನೀವು ಆಲ್ರೆಡಿ. Okay, so here in this complex Cu is present in +2 state. That is what, argon 3d9 4s0. ಹೌದಾ? 4s0 you will get. So if you try to draw the orbital diagram for the what, the Cu+2, that is what, 3d9 4s0. See here, confusion start ಆಗುತ್ತೆ. This is the 4s, this is your 3d, 9 electrons are there, 1 2 3 4 5 6 7 8 9. ಹೌದಾ? Yes. See here, ammonia is a strong ligand, sir. Ammonia is what? Strong ligand. If strong ligand is there, pairing of electrons should take place here. Pairing ಆಗಕ್ಕೆ ಇಲ್ಲಿರೋದು ಒಂದೇ ಒಂದು ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್. So ಹಾಗಾಗಿ what VBT explains is, this is 4p, this electron will jump to the what, one of the p orbital, that means one of the 4p orbital ಹೋಗಿ ಈ ಎಲೆಕ್ಟ್ರಾನ್ ಕೂಡುತ್ತಂತೆ. The electron excites from 3d orbital to 4p orbital, and these two 1, 2, 3, 4 orbitals involved in what? Hybridization. That means what? dsp2 hybridization. dsp2 hybridization ಆಗುತ್ತೆ. dsp2 hybridization ಅಂದ್ರೆ ಯಾವುದು ಸ್ಟ್ರಕ್ಚರು? ಸ್ಕ್ವೇರ್ ಪ್ಲೇನಾರ್ ಅಂತ ಹೇಳ್ಬಿಡ್ತೀವಿ, ಹೌದಾ? ಸ್ಕ್ವೇರ್ ಪ್ಲೇನಾರ್ ಅಂತ ಹೇಳ್ತೀವಿ. So here the confusion was there. Adappa, there is a strong ligand is there, no pairing of electron takes place. Here what it is happening? Electron is shifting from 3d to 4p, one of the orbital ಅಲ್ಲಿ 4p ಹೋಗಿ ಕೂಡ್ತಾ ಇದೆ. And in between orbitals are undergoing what? dsp2 hybridization in order to accept the what? The 4 ammonia ligand. ಹಾಗಾಗಿ dsp2 ಸ್ಕ್ವೇರ್ ಪ್ಲೇನ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಬಟ್ ದ ಥಿಂಗ್ ವಾಸ್, ಯಾವಾಗ ESR ಸ್ಟಡಿ ಮಾಡ್ತಾರೋ, ESR ಸ್ಟಡಿ ಮಾಡಿದಾಗ ಏನು ಗೊತ್ತಾಗುತ್ತೆ? ದ ಎಲೆಕ್ಟ್ರಾನ್ ವಿಚ್ ಇಸ್ ಪ್ರೆಸೆಂಟ್ ಇನ್ ದಿ ಎಕ್ಸೈಟೆಡ್ ಸ್ಟೇಟ್ ಇಟ್ ವಿಲ್ ನಾಟ್ ರಿಮೇನ್ ದೇರ್ ಪರ್ಮನೆಂಟ್ಲಿ. ಅದು ಪರ್ಮನೆಂಟ್ ಆಗಿ ಅಲ್ಲೇ ಇರೋದಿಲ್ಲ ಅಂತ ಹೇಳುತ್ತೆ. ಆದರೂ ಕೂಡ ಇಟ್ ಇಸ್ ಶೋಯಿಂಗ್ ದ ಜಾಮೆಟ್ರಿ ವಾಟ್? ಸ್ಕ್ವೇರ್ ಪ್ಲೇನಾರ್, ಹೌದಾ? ಸ್ಕ್ವೇರ್ ಪ್ಲೇನಾರ್ ಜಾಮೆಟ್ರಿನೇ ತೋರಿಸೋದು ಅಂತ ಹೇಳ್ತಾರೆ. ಸೊ ಬಿಕಾಸ್ ಆಫ್ ದಿಸ್ ರೀಸನ್ VBT ಫೇಲ್ ಟು ಎಕ್ಸ್ಪ್ಲೇನ್ this complex CuNH taken 4 times plus 2 complex ion in a geometry na helike. It was what? It was not at all giving the consideration values about the what? Valuable explanation about these type of complexes in which the geometry was very confusing. So illinda one electron illi hoytu, adu kuda higher energy level. We all know that electron won't stay longer in the energy level, higher energy level. It will jump back to its ground state. ಎಲ್ಲರೂ ಗೊತ್ತಿರೋ ಹಾಗೆ. ಹಾಗಾದರೆ ಸೊ ದಿಸ್ ಈಸ್ ಹೌ ಈ ಎಕ್ಸ್ಪ್ಲೇನ್ ದಿ ವಾಟ್ ಇಟ್ ಈಸ್ ಹ್ಯಾವಿಂಗ್ ದ ಸ್ಕ್ವೇರ್ ಪ್ಲೇನ್ ಅಂತ ಹೇಳ್ತಾನೆ. ಬಟ್ ದ ಥಿಂಗ್ ವಾಸ್ ವಾಟ್? ಆ ಒಂದು ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಯಾರು ಕೂಡ ಕರೆಕ್ಟಾಗಿ ಅನ್ನಿಸ್ಲಿಲ್ಲ. ಸೊ ಹಾಗಾಗಿನೇ ಬಿಕಾಸ್ ಆಫ್ ದಟ್ ರೀಸನ್ VBT ಡಸಂಟ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಅಬೌಟ್ ದಿ CuNH ಟೇಕನ್ 4 times plus 2 ಟೈಪ್ ಆಫ್ ಕಾಂಪ್ಲೆಕ್ಸ್ ಇನ್ ಇದಟ್ ಈಸ್ ಸ್ಕ್ವೇರ್ ಪ್ಲೇನಾರೋ. ಎದಕ್ಕೆ ಸ್ಕ್ವೇರ್ ಪ್ಲೇನಾರ್ ಹಾಗಾದ್ರೆ ಅಂತ ಅದು ಕೂಡ ಎಲ್ಲೂ ಹೇಳಿಲ್ಲ. ಇನ್ ದ ಸೇಮ್ ವೇ ದ ಜಾಮೆಟ್ರಿ ಲೈಕ್ ವೆದರ್ ಇಟ್ ಇಸ್ ಟೆಟ್ರಾಹೆಡ್ರಲ್ ಅದು ಕೂಡ ಹೇಳಿಲ್ಲ. ಇದೇ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಅಲ್ಲಿ even D2sp3 and sp3d2 both are showing what? Octahedral geometry. ಸೊ ಒಂದು ಕಾಂಪ್ಲೆಕ್ಸ್ ನೋಡಿದ ತಕ್ಷಣ ಇದು ಕೂಡ ಆಕ್ಟಾಹೆಡ್ರಲ್ ತರ ಕಾಣ್ತಾ ಇದೆ, ಇನ್ನೊಂದು ಕೂಡ ಆಕ್ಟಾಹೆಡ್ರಲ್ ತರನೇ ಕಾಣ್ತಾ ಇದೆ ಜಾಮೆಟ್ರಿ. Then when you go into the in-depth, then only you know what? Oh, this is going D2sp3 hybridization, it is having sp3d2. So like this, many confusions were there with respect to what? Valence bond theory. So ಹಾಗಾಗಿನೇ ಒಂದೇ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಹೊಂದಿರುವಂತಹ ಮೆಟಲ್ ಅಯಾನ್ ಒಂದ್ಸಲ ಲೋ ಸ್ಪಿನ್ ಒಂದ್ಸಲ ಹೈ ಸ್ಪಿನ್, ಹೇಗೆ ಗೊತ್ತಿಲ್ಲ. ನಮ್ಗೆ ಆಮೇಲೆ ಗೊತ್ತಾಯಿತು ಬಿಕಾಸ್ ಆಫ್ ದಿ ವಾಟ್? ದ ಸ್ಟ್ರಾಂಗ್ ಫೀಲ್ಡ್ ಲಿಗ್ಯಾಂಡ್ ಅಂಡ್ ವೀಕ್ ಫೀಲ್ಡ್ ಲಿಗ್ಯಾಂಡ್ ಅಂತ. ಸೊ ಹಾಗಾಗಿ ಇಟ್ ನೆವರ್ ಎಕ್ಸ್ಪ್ಲೇನ್ಡ್ ಅಬೌಟ್ ದಿ ವಾಟ್? ಪ್ರಾಪರ್ ಜಾಮೆಟ್ರೀಸ್, ಎಸ್ಪೆಷಲಿ ವಾಟ್? ದಿಸ್ ಕೋಆರ್ಡಿನೇಷನ್ ನಂಬರ್ 4 ಆ್ಯಂಡ್ ಕೋಆರ್ಡಿನೇಷನ್ ನಂಬರ್ 6. ಯಾಕೆ? ಒಂದು ಸ್ಕ್ವೇರ್ ಪ್ಲೇನಾರ್ ಮತ್ತು ಟೆಟ್ರಾಹೆಡ್ರಲ್ ಅಂತ ಹೇಳಲಿಕ್ಕಾಗಲಿಲ್ಲ. ಇನ್ ದ ಸೇಮ್ ವೇ ಇಟ್ ಡಿಡಂಟ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಅಬೌಟ್ ದಿ ವಾಟ್? ದ ಜಾಮೆಟ್ರಿ ಫಾರ್ ದಿ ಕೋಆರ್ಡಿನೇಷನ್ ನಂಬರ್ 6, ವೆದರ್ D2sp3 or sp3d2 ಅಂತ. Both were having same octahedral geometry only. So alli VBT failed to explain the what? The geometries of some of the complexes like CuNH taken 4 times plus 2 and all those things. And the seventh limitation, not the postulate, it's a limitation. Seventh limitation is VBT fails to explain the reaction rate and mechanism of the reaction with the complexes. So it never explains about the rate of the reaction as well as in which mechanism the reactions are undergoing with the complex. Adellu kuda helilla. Okay. In the same way, the eighth limitation is in VBT the more attention was given to metal orbitals rather than ligand. Ade helidannalla. That is what we have discussed earlier itself. So VBT never explains about the type of the ligand or the orbitals of the ligand. It only explains about the what? Metal and metal orbitals. So hagagine the more attention was given to the metal orbitals rather than the what? The ligands. So in the ninth limitation was VBT failed to explain the what? The correlation between the geometry of the complex and its magnetic behavior of many of the complexes. So ಕೊಟ್ಟಿರುವಂಥ ಕೋಆರ್ಡಿನೇಷನ್ ಕಾಂಪ್ಲೆಕ್ಸಿನ ಜಾಮೆಟ್ರಿ ಆಗಿರ್ಬೋದು, ಇನ್ ದ ಸೇಮ್ ವೇ ಇಟ್ಸ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಪ್ರಾಪರ್ಟಿ ವೇರ್ ಸಮ್ವಾಟ್ ಮಿಸ್ಲೀಡಿಂಗ್. ಮೆನಿ ಆಫ್ ದಿ ಕಾಂಪ್ಲೆಕ್ಸಸ್ ವೇರ್ ಮಿಸ್ಲೀಡಿಂಗ್. ಸೊ ದಟ್ ಈಸ್ ಹೌ VBT failed in order to explain the what? The coordination complexes. So ಹಾಗಾಗಿನೇ VBT failed in order to study the coordination complexes or the coordination compounds. ಇಷ್ಟೆಲ್ಲ ಡ್ರಾಬ್ಯಾಕ್ಸ್ ಇರೋದ್ರಿಂದನೇ we required another modern theory. ಮತ್ತೆ ನಮ್ಗೆ ಹೊಸ ಥಿಯರಿ ಎದಕ್ಕೆ ಬೇಕಾಯಿತು? in order to learn the coordination complexes because of all these drawbacks. So ಹಾಗಾಗಿನೇ the next theory came into existence, that is crystal field theory. So ಈ crystal field theory ಬಗ್ಗೆ yes we will discuss in the next part. Before that, those students who have not able to watch the part 1 and part 2, just go and watch, then you will understand the limitations. Okay, yes, fine, thank you.